Hello, can you hear me, Dr. Norma?
Yeah. Hello,
Oh,
good morning.
good morning. It's very raining very heavily here.
Okay. I'm just curious. Oh, Mages is not joined yet. Hopefully everything will be okay. Not about electricity or something.
No, we don't have electricity problem.
All right.
Very rare. We
Mm-hmm.
I can't remember when the last we had electricity, but internet is very often. And now it's 12 o'clock here, but the rain is terrible. Very
Okay.
heavy, so maybe that's why I couldn't connect. I'm using my data from my phone,
Uh-huh.
not my
Not
no.
by
Yeah,
with
my
the FO.
yes, the Wi-Fi that I have at home totally
Mm.
not working, so I'm connecting using my phone.
Okay. Hopefully
So
the provider also had no issue.
yeah. So
Yeah.
okay, so let me start from where I stopped last week, the video, right?
Yes.
Yeah.
Okay.
Okay.
Yes. Thank you very much, Dr.
Right,
Marquez.
right.
And it's yours.
Okay. Thank you, Dr. Norma. Sorry for the slight delay. And I stopped last week at the video, and also I have give all of you some introduction to the four phases of the conceptual change model.
Mhm.
So if you want your treatment to go through, you want your treatment to successfully address the misconception of your students. So you must make sure that whatever teaching that you are conducting in schools, that teaching must go through the four phases of Posner's conceptual change model. Okay, so similarly, what we did, I have showed you several examples last week. So what we have done is. Uh, this is actually in progress lah, not to say we completed. So that's why I just want to share one video with you all. Then from there, I can actually explain to you how the four phases of misconception we have addressed. Okay, right. Hold on. Okay, I have downloaded the video. I don't know why. I can't share the video. I don't know why.
Oh, the last week video?
Yeah. Do you maybe you can watch the video on your
Yeah. I will try to open it.
yeah.
Oh, hold on.
Oh. Can you open the video?
Let me try from here.
Okay.
Yeah. Okay. Okay, let me try it. Okay.
Are you sharing it now?
Not yet, because we could not download the video, just only play. So hopefully there is no WhatsApp come to my. Yeah. Okay. I will play it now.
Okay.
Could you see it, students? Can you hear it?
Belum, Bu.
Belum, Bu.
I don't know why I'm having problem.
Okay. It works, right? It works?
Yes. Yeah. Can see now.
Bisa ya?
Okay.
Okay,
Yeah.
okay.
So
One.
you start from the beginning, Dr.
Where
Norma?
the steer
All right.
gets its energy.
Okay. Okay, can stop now. Can stop. Pause. Okay, so now you can see there is 4 lessons here. Okay, so these 4 lessons were designed to address the misconception on climate change. So I don't have time to go through all the lessons. So the video that we are showing is only for lesson 1. So in lesson 1 we have 6 activities. So these activities, when we take the video, we just what you call that, we run the program and then we just shoot the video. But when the student really when the student interactively handle the software, each activity will take about 10 minutes, 10 to 15 minutes. Like activity 4 and 5 will take a bit longer, maybe like 15 minutes, but for activity 1 is less than 10 minutes. So each activity takes time. So the entire lesson 1, it takes about 40 minutes to complete. So what I'm showing now is just a video where we have recorded how the program works, for me to show the 4 stages of misconception. Okay, you can play the video of the normal.
Activity 1. Where does the Earth gets its energy?
So the sun, if they click moon, it will be
again.
it will be incorrect answer. So sun is the
That's
correct answer.
Good job.
So here you can pause for a while. Teacher probe further by asking more questions. So the teacher asks more question about, it's just not stop there. Teacher probe the students to asking more question. So this, always remember, this is for lower secondary school students. It's about 13 to 14 years old. So they still, some of them still have problem of knowing where the energy comes from. Okay, so in order for them to get the correct understanding, teacher showed that first app application, and then she continue asking more questions, and from the answers given by the students, and also from the explanation given by the teacher, students came to the situation whereby they felt dissatisfied with their understanding. Okay, can continue now.
Exercise sheet 1.
Okay, you can stop here.
Oh, before.
Yeah.
Before.
So
This one?
yeah. So they handle the software themselves, the application themselves. So from there, they got to know that sun sun actually releases rays that is reflected at the surface of the earth, and so on, and with some explanation from the teacher. So students also continue answering the exercise given by the teacher. So this exercise is performed in group. So it's not an individual work, it is a group work. So each of them, this total AR app is run using mobile phone. So students sit in a group when they handle the application. So when answering this, you can go through the questions later. This section, the one on the right, is very important. So it says that draw a single diagram to display. So I mentioned about stream just now the other day. To stream, the R stands for reading and writing. Later, I will share with you the lesson plan the teacher used, So the R stand for reading and writing. So the drawing that the student produced here reflects the reading and writing that will be infused. It's not only about reading and writing stream. R stands for reading and writing, and the A is the arts. So in our case, we don't want to say like in the Korean context, when they introduce STEAM education, the A stands for arts, correct? The A. But always remember, STEM education is very much context based. It is depend on the situation where you are implementing the STEM education. So when we do it in the local Malaysian context, we find it it's quite difficult to follow the suggestion given by the Koreans, because the Koreans' perspective is very much on the arts. That means it is more than just drawing and drawing or modeling or it's more than that. It also involves like artistic activity, for example, dancing, singing, and all that. More of artistic activity. But in a Malaysian context, it's very difficult to do in that way, because our education is so structured. You want to bring outside people into the system, it's not that easy. We even we want to involve the parents also, it is very, very difficult. So we feel like the A by the Korean is not so much suitable for the Malaysian context. So what we did, we changed the big A become a small A. The small A indicates that it's not only about singing and the other artistic way of teaching science, but we imply the small A with models. That means drawing, representation, diagrams, graph. Koreans also have that kind of idea, but ours, we are not going beyond that, because in Malaysian context, it is impossible. It never will happen. The A like artistic A, that's very impossible. So we imply that more like modeling, where the arts come in as a modeling. So in this drawing, when the student creates the diagram, the students were purposively asked the student to come up with the diagram. In the diagram, they will be advised to use as much as whatever diagrams they intend to. They can draw in any way they like. They can include graph, they can include pictures, they can include photos, or whatever they want to do. But as long as each diagram must have explanation. So there is also reading and writing, and also some kind of drawing. I will show you in the lesson plan later.
But art still abbreviation from A is still from art, right?
Yes. That's why we use small A.
Small A. All right. Could I continue?
Yep.
All right.
Once the sunlight reaches the Earth's surface, what happens? How energy is absorbed, radiated, and reflected from the Earth? Think of the roles of clouds, land, and water. Fill in exercise sheet 2.
Okay, you can stop here. So here, teacher, not only teacher, the student also learning themselves, because this application it can stand by itself. Student can actually do their own learning, but in the classroom, the teacher also discusses together with the student. Okay, students with the roles of clouds, land, water in absorption of radiation and energy reflection. So now, initially they were dissatisfied, but now she is putting the idea about energy from the sun in more intelligible manner for the students to understand. So it's not like you simply give them information, they would understand, but they have to do several activities. So activity 2 is one of the activity where the teacher had made the effort to make the information intelligible. So you always remember, I'm saying teacher because this is done in the classroom, but actually the app, the student can operate themselves at home. So by just learning using the app itself, the knowledge that energy is from the sun is made intelligible. So it made it in a way, presented in a way easy for the students to understand. So the first level dissatisfied, the second level is intelligible. Okay, now can continue. Yeah, the 3D dimension and exercise sheet. Yeah, can continue.
Activity 3. How much energy reaches the Earth? Fill in exercise sheet 3.
Okay, it's okay.
Yeah, it's done.
Yeah, but you can watch yourself because we have shared the video with you all, right? So
Yeah.
no problem. So if you see in the lesson 3, 4, 5, okay, lesson 3, 4, 5, yeah, you can actually go back and see later. It is mostly focused on the the intelligible phase and plausible phase. So make it presenting the information in more easily understandable way, and then plausible. That means we use 3D dimension, 3D view of how the energy, the ray from the sun is absorbed by the Earth's surface, and how the some of the energy is reflected back to the sun. So we have used 3-dimensional presentation in which the student also can actually they can handle they can interactively handle the app. So that actually makes the learning believable, they understand. And finally, if you see the activity 6, they have to do some kind of drag and drop activity, so that drag and drop activity is really based on the real world experience where it makes the learning fruitful. So you can see the 4 stages. Now I want to share with you the lesson plan, so that will be more helpful for you. Let me show the lesson plan. Okay, can you see the lesson plan now? Word file that I'm showing. Okay, so now you see here, content standard is learn energy flow in ecosystem. So this topic, this lesson is infused within this energy flow in ecosystem. Okay, so the learning standard is explained the examples of procedure, producer, consumer. So don't worry about that. There are many more lessons, following lessons, but in our intention is just to tap on one. State the main source of energy, describe Earth's energy budget and how energy flows through various parts of the Earth system, explain energy transfer from producer to consumer. This is also a phase where the students realize the learning is fruitful when they see how the energy is transferred from the producer to the consumer, and define producer, consumer, and so on. So the prior knowledge, now you see here, stream is science, arts, mathematics, reading and writing. Okay, right. So time allocated is 1 hour. Now we go by phases. So the first phase is something got to do with activity 1. So later I also will share this lesson plan. Then you can match with the activity. So it's easier for you. Teacher share objective of the lesson of the day. Teacher pose question. What does the earth, where does the earth get its energy? Teacher instructs students to use mobile apps in a group of 2 to seek the answer to the question asked. So students choose the answer. Students choose the sun as the answer to the question posed by teacher, the image figure 1 popped out. So you refer to the diagram, the video that I gave it to you. Students were given 5 minutes to discuss and reflect their discussion to the whole class. So in this section, you can see that science, reading, writing, and technology is involved. What is the science component? I'm touching on the STEM right here. What is the science here? The science is energy from sun. The knowledge of energy, earth gets its energy from sun. Reading and writing is the material. Teacher provided some additional material for the student. Always keep in your mind, this is a lower secondary school student. If it is higher secondary or high school students, we can actually restructure the teaching. But here the student needs teachers' help. We cannot let them go independently. But the app itself can stand by itself. So the element of reading and writing and technology here is refer to the augmented reality that we use. The augmented reality that we have used. And then the second activity is radiation, absorption, and reflection. So the activity here is the one in the video. So you can refer to the video. Teacher continue asking following question. Once the sun reaches the earth's surface, what happens? How energy is absorbed, radiated, and reflected from the earth. So you can see that students were asked to click let's explore. So they explore themselves. Actually, the teacher not giving them any information. They explore themselves through the AR application, and they got the understanding. Finally, at the end of the activity 2, they got the understanding. Oh, how much energy is actually Earth receives from the sun. But then not all the energy are absorbed by Earth. Some are reflected. So you would see it here at this stage. There are two levels, two phases happens. At stage 1, or initially when the teacher exposed, there is some dissatisfaction. But then at the end of activity 2, not that the entire dissatisfaction is addressed, but the students, when they explore, they manage to understand. The knowledge is presented in intelligible manner. So they manage to understand, but they never fully understand yet. They have to go through activity 3. Okay, they have to go through activity 3. So in the activity 3, teacher asked students another question: how much energy reaches the earth? Then the students were given, were asked to go back to the app and also explore further. And if you realize there is a link for video, the students also asked to watch the video animation version of Earth energy budget, and also they answered the question exercise sheet 1, whereby there is a drawing as well. So here the knowledge is made intelligible. Attempt has been made to make the knowledge easily understandable for students. Activity 3 also the same thing. We enhance on it. So the students further understand. The knowledge were presented in a manner for the students to understand further. But believable is not occurring yet. It is only intelligible, second phase of Posner's model. When come to this stage, if you watch the video, we have given albedo. The student can swipe and then they can check what is the albedo effect. You know, albedo effect is when the color of earth is very bright, more energy will be absorbed. Less energy will be reflected back to the sun. So in the case of snowing, that's why snow melts very fast during the climate change, because snow cannot retain energy. So the white color makes it more energy. Snow will absorb more energy. So that's why it the snow melts easily. So that's why during climate change, melting of snow is one of the consequences of climate change. So you can actually play with the slider, and then you can check how much of energy is absorbed at the dark space. We have given a road dark space, and the green space, and also white space. The white space is the snow. So it's the application of what they have learned in the activity 3. In the activity 4, they apply. And in the activity 5, it is drag and drop activity. So they can actually drag and drop and then match the answers. So this phase here, it makes the learning plausible. The knowledge is plausible. Here is intelligible. The knowledge is presented in a way for the students to make sense, for them to understand. But here, the activity 4 and 5 is plausible. They believe, okay, they believe, oh, my understanding that I got from activity 2 and 3 works in activity 4 and 5. Okay, so in activity 6, it is more on transfer of energy from producer, consumer, and decomposers. So they will realize whatever they have learned in activity 2, 3, 4, and 5, it is applied in when they handle the activity 6. So this activity 6 is fruitfulness. Okay, and throughout all these 6 activities, you can see the STEM element. Okay, STEM element is the science, which is the energy flow and energy transfer, reading and writing, mathematics. Mathematics is calculation of amount of energy that is reflected or energy absorbed, and also technology. Now, in this case, I would like to, you see, in STEM education, technology, I cannot say the AR, augmented reality, that I'm using to teach the student as a platform is not actually a technology in STEM. There are many definitions about STEM. So, some advocates of STEM, they said that even you use PowerPoint, that is considered a technology, but that one it's not really integrated STEM. When you're teaching integrated STEM, the technology that integrated STEM refers to is how students apply engineering design process, students participating in engineering design process in order to come up with some kind of product. They have to formulate a new product. So the product can be not necessarily must be a tangible product which you can see in your eyes. It also can be a kind of solution for a problem. That is also considered a product. So the solution that you derive is a new technology. The solution that you comes up to the problem that you have given to the student work together, they engage in engineering practices, they participate in the engineering, they explore the technology, they participate in the engineering design process in order to come up with a product, or in order to come up with a solution for the problem. So that solution is a new invention. Okay, that solution is a new invention. So that invention refers to the technology in integrated STEM teaching. So in this exercise, in this lesson 1, probably the element of technology is not very clear, but the element of technology will be clear when the student completed all the 4 lessons, right? Just now 4 or 5 lessons. What I'm showing now is only lesson 1. So the element of technology and the element of engineering process design is very clear when they have completed all the 4 lessons. Do you understand what I'm saying? Okay, let me repeat. Just give me a few minutes. Now you have STEM, science, technology, engineering, mathematics, right? You see, if you see this STEM, people have defined STEM in many ways. Okay, one of the definition of STEM is science is the science concept that we are using. Elements, you integrate the elements of mathematics or some calculation in the STEM, and also you have engineering and technology. the always problematic with the science educators are the engineering component and the technology component. So the technology, some advocates of STEM, they have presented technology is the any kind of technology you use in teaching. For example, in my teaching, I'm using AR, augmented reality. So I can simply say AR is representing the technology in my STEM teaching. And I can say the students are given a problem, a real world problem. So the real world problem is not in the lesson 1. The real world problem is in the lesson 4, later part. Okay. So they were given a real world problem. They have to use the information on the knowledge from lesson 1, lesson 2, lesson 3, apply the knowledge and solve the real world problem. When they solve the real world problem, they're coming out with a new solution. They're coming up with a new answer. They also come up with a product. So the process of coming up the new product or coming up with the solution, in the process of coming up with a solution or new product, they engage in engineering design, engineering thinking. So that is the element of engineering there. So what is the technology here? The technology here refers to the new solution that the student have produced. The new solution to address climate change. The new solution to reduce global warming. The new solution to avoid ozone, to avoid acid rain or something like that. So that is the technology, that the invention, the new information that the students have actually derived from participating in their STEM activity. Okay, reading and writing. You see, when we use integrated STEM, science, technology, engineering, mathematics, these 4 elements cannot stand separate distinctively. These 4 elements must be merged. You know, they must come together. The science and mathematics must come together. The engineering process, engineering design process that I've said, it also must be within the science, the science and mathematics. You know, and the technology also must be integrated within the teaching. So you cannot say, okay, let student do the engineering protest something, I'm teaching the science some concept somewhere. It's not like that. It should be merged. So for a science educator, we always have a problem of how to bring this thing together. So one way of doing this is having reading and writing activity, as well as infusing the modes, which is the arts component. So this is what we are doing now. I have one paper accepted with major correction regarding stream. So I hope the paper will be accepted. If the paper is accepted, I will share with Dr. Nurma, and she can share with all your the fellow students, and you will get a very clear picture is what is the meaning of stream. So maybe one day you can invite me, I can share with you all this info, and you can take it and try to do it in your context or something like that. Okay, right. So what I'm trying to in order to understand STEM, maybe I need to give more example and so on. But what I'm trying to say for purpose of today's lesson, whatever constructed in the lesson 1, it corresponds with the 4 phases of Posner's conceptual change model to reduce misconception. So this is one of my PhD students' work. She's also a teacher in secondary school. And one of a variable here is misconception. She have actually measured misconception pre and post test. So our finding, we just analyze our quantitative finding. The quantitative finding, actually, the misconception got 4 subscale: global warming, acid rain, ozone layer, greenhouse effect. In the quantitative finding, she find out that global warming and ozone layer is significant. But then acid rain and greenhouse effect is not significant. It's not much of changes. But the qualitative finding that she obtained, it shows that the students have a clear picture of how their prior misconception, they had misconception on greenhouse effect, but then after the treatment using this AR, what kind of misconception has reduced? By we only managed to find out in the qualitative finding, but not in the quantity. Okay, so once the study is complete, maybe I can share with you. Okay, so that you can take this lesson plan, I will share with Dr. Norma, then you can match with the video. Then you will understand better. Okay, so I think I'm done on my part. So I'm happy to see the students.
What?
Yeah, if they have.
Hopefully they have, because preparing for 1 week or 1 day, I'm not sure. Just
It's okay as long as they can show me something. Then you know we can work on it. And some more, I see your master student. How many of them?
Two classes for 10 students.
Yeah, so if these 10 students, if they really work on it, in coming out with a intervention, maybe we can try to publish for publication, you know. Make sure you do a good job. So you can always approach me. I'm willing to work with you and guide you to bring you to that level. No, it's not a problem.
Yes, students, you have to take this opportunity with the Dr. Mages. Okay, Dr. Mages, we are continuing the session. All right.
Yeah.
Okay. Could I stop your screen or?
Yes, I will stop the screen. The students can share. Yeah.
Okay, students, for my 10 students, my beloved student in BBA and also BBK, hopefully you have already make a group, right? Grouping of 2 students each. And please try to share anything that you could do in this week, from last week until today, about the misconception, and then what the things that you use to measure, to diagnose, and then try to share the strategies based on the CCM. All right. Oke, silakan siapa terlebih dahulu. Jangan lupa nanti presensi dibikin. Mas Gama dulu, Mas Haji dulu. Apa saja silakan bisa di-share. Siapa yang mau duluan silakan. Kelompoknya siapa saja? Mas Haji sama siapa?
Saya sama Mas Umam, Bu.
Mas Umam, Gama, Mas Gama?
Sama Mbak Dwi.
Oke, ya Mbak Dwi itu selalu menjadi nomor 1, the first coming in this Zoom meeting. So I would like to ask Mbak Dwi and Mas Gama's group, please. Time is yours.
Okay, let me share screen. Is my PowerPoint appear?
Yeah.
Yes, it's showing.
Okay. I'm so sorry, we are perhaps using bilingual bahasa Indonesia and Inggris.
It's okay.
Oke, jadi di sini kami semi penelitian di sini meneliti tentang miskonsepsi pada kesetimbangan kimia.
Chemical equilibrium, Dr. Mages.
Okay.
Chemical equilibrium. Jadi di sini kami mengembangkan instrumen tes, bukan mengembangkan secara valid ya maksud saya. Kami membuat 6 soal, yang mana tiap 3 soal itu sebagai representasi dari subkonsep. Yang pertama pergeseran kesetimbangan, selanjutnya kesetimbangan kimia dalam industri. Jadi 2 subkonsep tersebut kami teliti, kami berikan kepada 12 siswa kelas 12 yang berada di SMA dan 1 Pro asli Kediri, East Java, Indonesia. Jadi ini ada 3 hal yang akan kami bahas. Yang pertama instrumen tes, kemudian pembahasan, dan yang terakhir rekomendasinya. Ya, instrumen tesnya seperti ini. Kami menggunakan tes diagnostik two-tier multiple choice berbantuan GRI. Perhaps other question you can click link below. Untuk pembahasannya, soal tes merupakan soal pilihan ganda dengan 2 tingkatan disertai pemberian tingkat keyakinan. Jadi tingkat soal yang pertama itu soal umum, soal utama. Kemudian yang kedua disertai alasan, mereka memilih alasan yang tepat. Dan yang ketiga itu ada tingkat keyakinannya. Tingkat keyakinan dibagi menjadi 6. Di sini mulai dari 0 sampai 5. Dengan ketentuan seperti yang tertulis di PowerPoint. Ini adalah hasil angket hasil tes dari 12 siswa. Kemudian pembahasannya akan dijelaskan oleh Mbak Dwi.
Bisa di-share linknya, TTMC-nya Mas Gama di chat ya. Nanti Dr. Magis bisa lihat.
Iya, saya share.
Link Google Form-nya. Oke, silakan Mbak Dwi.
Baik, terima kasih Mas Gama. Di sini saya akan melanjutkan terkait dengan pembahasan. Nah, jadi setelah instrumen tes tersebut diberikan kepada siswa dan sudah dikerjakan, kemudian instrumen tes tersebut dianalisis dengan kategori tingkat pemahaman siswa seperti pada slide. Apabila pada tingkat pertama siswa itu menjawab benar, kemudian alasannya juga benar, kemudian pada skala CRI atau tingkat keyakinan siswa itu berada pada rentang 3-5, maka siswa itu dikategorikan memiliki paham konsep yang baik. Kemudian apabila jawaban pada tingkat pertama itu benar, pada alasan benar, sedangkan pada skala CRI itu 0,0-2, maka siswa dikategorikan memiliki paham konsep tapi tidak begitu yakin. Sedangkan kalau untuk kategori miskonsepsi, pada tingkat pertama siswa itu menjawab benar, kemudian pada alasannya itu salah, kemudian kategori skala CRI-nya itu berada pada skala 3-5. Maka siswa dikategorikan memiliki miskonsepsi pada materi tersebut. Next, Mas. Nah, kemudian dari kategori tersebut, maka secara garis besar identifikasi dari jawaban siswa itu dikategorikan menjadi 4. Yang pertama itu siswa yang paham konsep, kemudian siswa paham konsep tapi kurang yakin, kemudian siswa tidak paham konsep, dan siswa yang mengalami miskonsepsi. Kemudian untuk hasil analisisnya terlihat pada slide. Dari 6 soal yang diberikan, siswa mengalami miskonsepsi itu paling tinggi pada soal nomor 3 yang berjumlah 3 dan soal nomor 6 yang berjumlah 5 orang. Untuk soal nomor 3 seperti pada slide, begitu juga soal nomor 6. Selanjutnya terkait dengan strategi yang kami gunakan untuk mereduksi miskonsepsi yang terjadi pada siswa. Nah, jadi setelah kita ketahui bahwa pada materi kesetimbangan kimia itu, konsep yang ada di dalamnya itu sangat berkaitan erat dengan materi-materi sebelumnya, seperti pada materi laju reaksi dan stoikiometri. Nah, jadi dari analisis yang telah dilakukan, kita lihat bahwa terjadi miskonsepsi yang ada pada siswa. Nah, jadi strategi yang kami pilih itu adalah pembelajaran yang menggunakan strategi konflik kognitif, di mana strategi konflik kognitif ini termasuk strategi pengubah konseptual dalam upaya mengubah miskonsepsi siswa menuju konsep-konsep yang benar, gitu. Dan pada strategi konflik kognitif ini, permasalahan akan diberikan pada kegiatan awal sebagai suatu tantangan bagi siswa untuk dapat menyelidiki dan mengeksplorasi terkait dengan pertanyaan-pertanyaan yang akan diberikan oleh guru. Kemudian untuk tahapannya, nah jadi dalam fase strategi konflik kognitif ini terbagi menjadi 3. Yang pertama itu mengungkapkan konsepsi awal siswa. Kemudian yang kedua itu menciptakan konflik konseptual. Dan yang ketiga itu mengupayakan terjadinya akomodasi kognitif atau encouraging cognitive accommodation. Kemudian untuk fase pembelajarannya atau tahapannya ini, di awal itu siswa diatur ke dalam beberapa kelompok. Kemudian guru mendemonstrasikan suatu situasi untuk mengaktifkan siswa. Nah, kemudian apabila dimungkinkan untuk dilakukan suatu percobaan, siswa melakukan percobaan tersebut dan menghasilkan hasil yang bertentangan dengan pendapat mereka, sehingga akan membawa siswa dalam sebuah konflik kognitif, begitu. Kemudian para siswa diminta untuk mendiskusikan dari hasil percobaan dan ide-ide mereka. Tetapi jika percobaan tidak dimungkinkan dalam suatu proses pembelajaran, guru meminta siswa untuk membahas situasi yang sebelumnya yang telah didemonstrasikan oleh guru maupun teman-teman mereka. Kemudian guru mengumpulkan ide dari para siswa dan akhirnya didiskusikan bersama-sama di depan kelas antara para siswa. Kemudian ide-ide yang benar ditentukan dan dijelaskan secara rinci oleh guru. Mungkin seperti itu dari kelompok kami terkait dengan miskonsepsi pada materi kesetimbangan kimia.
Okay.
Hopefully Dr. Mages can understand.
Yeah, I think I can
Bahasa
understand
Indonesia.
not all,
Okay.
but most of it I can understand. Boleh share screen tak? Let me
Ya,
share the PowerPoint just now.
di-share lagi, Mbak Dwi. Di-share lagi PowerPoint-nya. Yang share screen siapa tadi? Oke. Ya.
Okay, saya nak tanya. So sekarang kajian ini sudah buat ataupun peringkat proposal atau cadangan?
Oh,
Kajian
tidak.
belum. Okay. My first question, where did you obtain the instrument? Instrument ni dapat dari mana?
Ya, saya
Ya.
akan menjawab. Jadi instrumen kami kembangkan sendiri dengan berbagai referensi, dokter.
Oh.
It's not a valid instrument. I think we just only develop this without validity.
Okay. So I'm just asking you, is it possible, because validating the instrument itself is another research, you know?
Yeah.
But and if you use an instrument which is not valid, the finding is also not valid. Okay, would that be possible for you to, or what you can do is, bila kamu ambil question items from different instrument, did you change the item or did you like just simply take?
Okay, jadi untuk soal most of source in internet is only give the question, not the reason. But here we develop it by adding a reason in below the question.
Okay, I understand. But because the question is not validated, we will have problem if then I can really question the validity of your results.
Okay,
No?
Dr. Mages, or maybe I can bridge the things because this is as a part of the task that they are doing in this in our 4 meetings. That's why they don't have any in purpose to do the validity process. I mean, they try to cite from literature, and then with this multiple choice, 3-tier multiple choice with GRI, maybe you can have the comment with this category? Is that okay, or how can they develop to get the more valid data?
Oh, you're asking my suggestion,
Yeah.
huh? If you ask my suggestion, is very easy. Use use instrument which is already validated.
Yeah.
So if you see one of my papers, I shared many papers. One of my paper, I have a questionnaire on chemical equilibrium. You can use that instrument. It is a well validated instrument. And also you can refer to Osman.
Yes.
So he also have done a lot of study on chemical equilibrium. So that's why I asked you the question: Is it like, if you can refer to my question item? My item, I worked with Tragas to develop the item. So my item and as also Osman's item, and you just pick and choose which item is appropriate for Indonesian context. That means you are just taking it. You are not changing the item. The moment you switch, the moment you change the item, you restructure the questions, then you have to find the validity really. So, but if you can just take one question from this questionnaire, one from that, one from here, and then you kumpul, you become one whole questionnaire for Indonesian context. You still have to check the validity. You can just ask some expert teachers to look at the questions, to verify. That is okay. But if you come up with own self, that is entirely another process. So without doing it, if you write an article, where is the validity of the instrument? The issue.
Yeah.
Okay. Right. And also the second thing is, as you said, maybe this is only a class, it's a course, it's a part of the course, right? So probably the students are trying it. It's okay. When you collect data, try to collect as much as the sample size should be big. From 12 students, you can't actually make any conclusion. So you can administer the questionnaire to a bigger group. And from that bigger group, you can come to a conclusion. And according to Tragas, if 10% of the respondent who answered your questionnaire has misconception, so then you can say that misconception is prevalent among the samples of your study. But if you just do with 12 students, it's quite impossible. Okay, these are my suggestion. The second thing, cognitive conflict that actually suggested by the student teaching. It's okay. Yes. So now, cognitive conflict, there are many ways for you to teach. Like even the AR I showed to you all, it is a kind of cognitive conflict because the student already have some prior knowledge. Now I'm showing them a new knowledge. So there is already a conflict there. What is correct? My prior knowledge or the knowledge from the teacher? So there is a kind of conflict there. So I suggest if you can specifically mention what kind of teaching. Now you are describing, you use that, you ask the students work in the group, and then you have some steps there. I agree with that. But how this is different from other cognitive conflict teaching? If this is already done, why do you need to do a research? You can actually refer the past research and you get the information one. So now you want to introduce something which is very new, that in Indonesia it's not done yet. So you can use the word cognitive conflict, but you need to be more specific on what kind of teaching that you are using. So your teaching must be different from other people's teaching. Other people also might have used some teaching which also have this element of cognitive conflict. Tapi your cognitive conflict is different from their cognitive conflict. That part you have to work on. Now currently, apa yang kamu bentangkan saya rasa tak ada beza. Dia sama saja. Saya tak nampak beza dia.
Yeah. Okay. Thank you,
Right.
Kama and Mbak Dwi. I will try. I will stop the screen sharing. And you have already tried to write the recommendation from Dr. Mages, yeah, to learn more, because they master thesis is regarding with AR. Maybe you can try to ask about AR in after we have this misconception meeting, Mas Kama and Mbak Dwi, yeah. Okay. Yeah. Okay. The next group, please.
So I would like to highlight here lah, instrumen tu sangat penting. Instrumen yang kamu nak guna tu is sangat-sangat penting. Kalau kamu tersilap instrumen, the whole study become not valid. You know, so that's why. Yeah. That's why when I conduct studies on misconception, I always go back to the instrument which has been published in good journals. So when you take from these kind of journals, they cannot cheat. They already validated. They have already confirmed the items work with their student. But only thing is, chemical equilibrium in Indonesia, the coverage might be different from chemical equilibrium that we taught for high school in Malaysia. You know, the objective chemical equilibrium is same. You go to any part of the world also, we still talk about chemical equilibrium. But for my high school level student, we only talk about Lee-Chatelet principle. We don't talk about the other components of chemical equilibrium. So if I go and question them, other than Lee-Chatelet principle, of course the student cannot answer because that's not part of the syllabus. You understand? So you have to get all these questionnaire. Then you pick and choose what are the items relevant to the Indonesian context, Indonesian syllabus. Then you are safe.
Yeah. All right. We need more time for the course for doing the real research, yeah, Dr. Mages, yeah. Yep. All right. Okay. Please, another group, if you want to share your idea, what you already got done, please. Silakan, kelompoknya siapa? Hampir sama seperti punya Kama.
Kalau saya ini sih Bu, mencoba membandingkan, kan Mas Umam itu kan di Makassar, bukan di Makassar, di Sulawesi. Kalau saya kan di Surakarta, itu ternyata ya dari instrumen yang sama tuh problemnya berbeda seperti itu.
Boleh di-share nggak apa-apa sama Dr. Mages? Ya.
Oke, Mas Umam, gimana Mas? Oke. Assalamualaikum warahmatullahi wabarakatuh. Thank you for the time and place. For our research, this is not actually a real research. This is our mini research. So for our material, for the subjects is acid and base. So the very foundation of acid and base in high school students. So Mr. Umam is from Sulawesi, eastern part of Indonesia, while I'm from Surakarta, so western part of the Indonesia. So Mas Umam, can you please explain the instrument first using Indonesian language? Is all right.
And send the Zoom process. Yeah. Okay. Already in Zoom.
Ya.
Oh, okay.
Oke.
Okay, so Mr. Umam, please explain.
Oke. Mungkin bahasa Indonesia saja. Ya. Terima kasih. Kali ini saya mengembangkan sedikit, bukan mengembangkan dalam arti saya mengadopsi dari beberapa instrumen. Ini saya ambil, yaitu yang pertama ini instrumen untuk miskonsepsi tentang asam basa. Nah, di dalam miskonsepsi ini, instrumen ini terdapat 10 soal, kemudian ada multi choice, yaitu dari A, B, C, dan A, B, C, D, kemudian ada reasonnya, alasan, kenapa dalam menjawab A, B, C, D ini kemudian disertai dengan alasannya. Nah, kemudian seberapa jauh keyakinan anak-anak itu dalam menjawab suatu materi. Nah, yang pertama adalah pada soal nomor 1 itu berkaitan tentang seberapa jauh anak-anak itu mengetahui tentang pH. Jadi ada pH dari 0 sampai 14 itu, kemudian mengurutkan dari yang memiliki ion H+, dari yang terkecil sampai yang terbesar. Nah, sebentar saya mau share sebentar sedikit. Nah, dalam instrumen ini ternyata juga hasil jawaban dari siswa. Bisa ditampilkan Mas Haji untuk jawaban siswa. Nah, ini instrumen ini tidak saya gunakan, saya tidak menggunakan untuk Google Form, tapi saya langsung print out, saya sebarkan langsung kepada siswa ke kelas 11 dengan 10 sampel siswa. Nah, di dalam hasilnya ini pada soal yang pertama itu masih adanya miskonsepsi bagaimana siswa itu menjelaskan tentang pemahaman siswa tentang pH. Nah, pada soal nomor 1 itu tentang pH merupakan suatu derajat keasaman atau ukuran konsentrasi ion hidrogen dalam suatu larutan yang digunakan untuk menyatakan tingkat keasaman dari suatu larutan. Nah, dalam skala pH 0 sampai 14 itu semakin rendah nilai suatu pH, maka keasaman suatu larutan itu semakin tinggi. Kemudian pada suatu basa juga sama, jadi semakin tinggi, semakin menjauh dari angka 0 atau menuju ke 14 itu, maka pH itu akan mendekati kebasahan. Kemudian nah, dari hasilnya itu bisa tampilkan datanya, Mas. Nah, ini hasil dari yang telah saya uji cobakan ke siswa pada soal nomor 1. Masih adanya miskonsepsi pada soal nomor 1, yaitu dari 10 siswa masih ada 6 siswa yang masih mengalami kesalahan konsep dan 4 siswa ini dengan menjawab pilihan yang benar. Siswa ini merasa kurang paham tentang konsep derajat keasaman dan hubungan dengan konsentrasi atau jumlah ion hidrogen. Nah, ketika ditanya terkait jumlah ion hidrogen terkecil, maka ion hidrogen dalam suatu jumlah banyak atau sedikit, siswa masih menjawab banyak. Selain itu juga siswa masih kurang paham tentang konsep derajat keasaman dan hubungan dengan konsentrasi atau jumlah ion hidrogen. Ketika ditanya terkait jumlah ion hidrogen terkecil, maka ion hidrogen dalam jumlah banyak atau sedikit, siswa masih menjawab dengan banyak. Nah, kemudian pada soal yang nomor 2 juga sama. Ya, ketika menjawab, siswa masih berpendapat bahwa pH 7 ini masih bersifat netral, sehingga memiliki jumlah ion hidrogen paling sedikit dibanding dengan yang lain. Setelah pH 7, siswa memilih pH 1, 5, dan 11. Sehingga pH yang memiliki jumlah ion hidrogen terkecil selanjutnya mengalami miskonsepsi. Jadi penyebab miskonsepsi pada nomor 2 ini masih belum mampu untuk menghubungkan
Saya nak tanya boleh?
Yes.
Okay. Macam mana kamu tahu yang itu miskonsepsi dan bukan pelajar tidak tahu? Bukan bermaksud jawapan salah itu bukan disebabkan dia miskonsepsi, salah faham, tapi dia memang tak tahu. Macam mana nak bezakan?
Ya, dalam penyebaran ini untuk penilaian pada setiap instrumen itu, jawaban yang A, B, C, D, E itu memiliki nilai kebenaran. Dalam arti kalau supaya menjawabnya benar, itu akan mendapatkan nilai poin 1. Kemudian kalau menjawab dengan alasan yang tepat, itu juga nilainya poinnya 1. Jika alasannya salah, juga poinnya 0. Kemudian dalam menjawab tingkat keyakinan, apakah siswa itu menjawab itu dengan yakin atau tidak, maka itu juga ada poin. Nah, ketika yakin ada pemberian skor 1, dan untuk yang tidak yakin itu pemberian poin 0.
So maksudnya katakan yang ini jawab A, multiple choice ini jawapan betul, alasan jawapan betul, tingkat keyakinan tidak yakin. So bermaksud yang itu miskonsepsi kah?
Rubriknya seperti apa, Mas Umam? Jadi yang layer 1 misalnya betul, layer 2 betul, tapi dia tidak yakin, kan mestinya itu gimana? Kalau dia tidak yakin, dia tidak tahu atau miskonsepsi. Kan dulu sudah disampaikan, ada perbedaan antara tidak paham dengan miskonsep. Nah, gimana membedakannya di sini? Sudah atau belum? Kalau belum disampaikan aja enggak apa-apa.
Tak ada apa. So, my advice to you is, kamu dah ambil soalan ni daripada literature kan? Kamu dah rujuk beberapa literature untuk dapatkan soalan ini, betul?
Yes.
So tengok balik literature tu, how the grading was done. You know, sometimes tier 1 salah, tier 1 betul, tier 2 salah, tier 3 salah, it is misconception. Some say in that way. But some say tier 1 correct, tier 2 correct, tier 3 is incorrect. So it's misconception. So you fall back to the literature. Tengok balik literature, kamu ambil soalan ini dari mana, bagaimana rubrik itu dicadangkan. Okay?
Untuk yang yang rubrik masih belum.
Ya, nanti dicek lagi gitu aja. Dicek lagi ke referensi yang dipakai.
Ya.
Terima kasih.
Right. So instrumen tu ambil dari siapa? Acid base.
Saya ambil adopsi dari sebuah tesis yang menggambarkan miskonsepsi tentang asam basa.
Okay, so itulah saya cadangkan kalau boleh gunakan reference yang reliable. You know, kalau thesis student, PhD student, master's thesis, I don't think it's reliable unless the student already publish the work in good journal.
Yeah.
You know, sekarang ada banyak journal lah, macam yang nowadays I see one popular journal is Jurnal Pendidikan Indonesia. Have you heard about it?
Jurnal Pendidikan IPA Indonesia.
Have you heard about that journal? Actually, a few years ago, it is free, you know, you can publish. But now I heard they are charging. I don't know how much they are charging, but you have to pay money. But I see the papers is anything you write also is getting accepted.
Yes, I know.
And its language also, it's like, and it's in Scopus, you know, it's
in
Scopus,
Q2, yeah.
Q2. So
Yeah.
if you tell me, let's say lah, sekarang you dah tulis dah buat research cantik-cantik, you have written nice article, you want to send to SERP, Chemistry Education Research and Practice, katakan, then the reviewer will see where you the instrument from Journal Pendidikan Indonesia. Then the reviewer will go and look at the journal. Hey, you take from Journal Pendidikan Indonesia, but it's okay if the journal is good, never mind. But then yang ini apa tulis pun boleh publish.
Yeah.
The review is not stringent, so then they will question what is the validity of the instrument. You understand? So if your instrument is not takuko, kamu sendiri dah buat satu pintu, satu halangan. Kamu sudah letakkan halangan kepada diri kamu, di mana kamu tak boleh nak kembang. You have already put a stop there. Then again, you can only go back to Journal Pendidikan Indonesia. You can't go to SERP or you can't go to JCE. You understand? So that's why I'm saying. And I see your work on, you know what you're doing. Why not you can try to collect data, more data, and then try to write something. You know, cubalah, tak salah.
Yeah. They have to continue to the research method with the next validity step, to end reliability. Okay, thank you, Mas Umam dan Mas Haji. Thank you very much. You can try to develop this kind of instrument because you are already real teacher and you experience how about your students, what they are thinking, what they are doing. You can try to develop and then try to follow the step for developmental research. So your instrument will be good and the result also will be valid when the instrument is not good. All right, thank you very much. You can stop your screen sharing. Dr. Mages, I have another issue here regarding not adapt, but we use another instrument. We use another instrument from published article. That's good, not in JPEE. I know that's public secret in JPEE like that. This also in Indonesia is a public secret. What they are doing there.
But then, it's not only Indonesia, it's in Malaysia also we have. But I am very careful.
That's why I am not cite any things from there.
I'm very careful. That's why I tell my students, when you want to cite journal, make sure you cite good journals. You know?
Yes.
Right.
That's right. When we want to use one good instrument from one good published articles, so without any restructuring, without any rewriting, and then we use that instrument, but we not try to maybe your article in Malaysia and Indonesia based on the curriculum, we have the quite range of topics, and then we use the instrument without the validity test, but reliability test. We want to know how the student is doing. How about your comment? So
okay, my comment is like very simple. You see, whenever it's not only misconception, it's not only
not only misconception.
Any instrument, whenever you take from somebody else, it's not wrong. Tak salah, kamu tak buat apa-apa salah. You boleh ambil soalan. Orang lain punya sudah publish, you boleh ambil. But the first step of you to use is you need to do validity checking and reliability checking. Even though you are using 100%, apa yang sudah publish, you just take. So what I mean the reliability validity here is, see, you must understand something. when just now your two students presented the questionnaire, I told them you need to check reliability, you need to check validity. That means they need to do a thorough development of instrument. So they must start from the scratch because they are doing the instrument themselves. They have to start from the scratch. Dari asas, kamu kena gunakan teknik penghasilan instrumen because instrumen ini kamu hasilkan sendiri. Tapi kalau you nak guna orang lain punya, what you need to do is kamu hanya perlu cek keboleh percayaan dan validity kesahan. So checking validity is you just give to the experts in Indonesia. Sure, they are experts.
Content validity.
Yeah, content validity, face validity, language validity, all these things. And reliability, you just key in inside alpha Chrombank. SPSS, you can get the alpha value. But if it's not a Likert scale, you can get the Kudo-Richardson, KR20 or 21. Then you can check. But you have to do it. As I said, for Malaysia, if the questionnaire is from Malaysia, chemical equilibrium thought, the concept, the coverage might not be the same with Indonesia or some other country. So maybe if got 12 questions, you might remove one because the other one question is not taught in Indonesian student. You have to do that.
Right. All right, thank you. Because even for the research method lecturer, it should be make sure you have to check this validity and reliability, even 100% cited. Citation. Please underline that, students.
You must check.
Sometimes we just do make a debate in the thesis exam about this.
Because the questionnaire is from somewhere else. Even let's say you are in Jakarta, okay? Another person developed the questionnaire in Sulawesi. Let's say example. When you want to use, you still have to check the validity.
Yes.
You need to check the validity. Someone must confirm these items are appropriate for this research. Someone must say, okay, you can do research. This item is good. So that is very important.
Okay. Yes. Okay. Thank you, Dr. Mages.
Right.
For the underlined statement for this kind of instrument that we try to do for the diagnose the misconception. Okay. Silakan, ada lagi satu kelompok lagi yang bisa mempresentasikan. Yang bisa jadi Anda menerapkan validity dan reliabilitas untuk instrumen Anda. Dari siapa? Mbak Reti atau Mbak Rahma? Teman-teman semuanya. No one, Mages. No one, Dr. Mages. Okay, so only two groups that can share the idea and share the works today. Hopefully this is as the feedback from Dr. Mages is very insightful for you to learn more and explore about the misconception. And then do you have another question to Dr. Mages? Oh, Mbak Reti on cam mau sharing?
Saya mau, ya Bu. Saya dengan
okay, one group more.
Yeah,
Dr.
sure.
All right. We still have time till 12:45.
I will share screen, Bu.
Yes, silakan.
Baik, terima kasih atas waktu yang diberikan. Di sini kelompok kami menggunakan retire test untuk mendeteksi miskonsepsi hidrolisis garam. Nah, tes ini dilakukan pada siswa kelas 11 IPA 4 dan juga IPA 6 sebanyak 69 siswa. Bentuk soalnya adalah retire multiple choice. Jumlah butirnya adalah 14. Siswa diberi waktu 60 menit
untuk mengerjakannya. Nah, berikut adalah hasil untuk ketuntasannya.
Ini
Sebanyak
di Mbak Reti,
74
penelitian skripsimu ya?
penelitian skripsinya itu Bu, Mbak Rahma.
Oh ya, oke.
Nah, kemudian ketuntasannya sebanyak 74%. Nah, untuk tabel klasifikasi pemahaman konsepnya, untuk mengetahui apakah dia paham konsep, miskonsepsi, atau kurang paham, atau tidak paham, ataupun untung-untungan itu diambil dari Susilaningsih 2016. Kemudian untuk hasil analisisnya sebanyak 60,56% itu yang paham konsep dan juga yang miskonsepsi sebanyak 25,98%. Untuk yang untung-untungan itu sebanyak 5,90%. Untuk yang kurang paham itu 5,38% dan yang tidak paham 2,17%. Kemudian ini adalah persentase dari hasil analisisnya untuk tiap indikator, di mana indikator untuk siswa yang mampu menentukan sifat garam yang terhidrolisis itu mengalami miskonsepsi yang terdeteksi sebesar 52,17%. Dan untuk yang indikator siswa mampu memberi penjelasan tentang kesetimbangan ion dalam larutan garam itu sebesar 53,62%. Berikut adalah analisis tiap indikatornya. Pada indikator identifikasi prinsip hidrolisis garam itu sebagian besar siswa sudah paham konsep, namun ada beberapa juga yang masih mengalami miskonsepsi. Berikut adalah grafiknya. Begitu juga pada indikator mengamati perubahan warna kertas lakmus dan indikator universal dalam beberapa larutan garam. Indikator sifat garam yang terhidrolisis itu untuk butir soal nomor 4, dia sudah sebagian besar sudah paham konsep. Namun untuk butir nomor 5 itu yang miskonsepsi itu sebesar 52,17%. Dan kemudian untuk indikator kesetimbangan ion dalam lautan garam pada butir 8 itu juga mengalami miskonsepsi sebesar 53,62%. Dan ini adalah indikator-indikator lain yang sebagian besar sudah paham konsep. Kemudian untuk deskripsi miskonsepsi pada siswa akan dijelaskan lebih lanjut oleh Mbak Rahma.
Baik, terima kasih. Untuk deskripsi miskonsepsi pada siswa, persentase siswa yang mengalami miskonsepsi itu sebesar 25,98%. Nah, miskonsepsi ini didasarkan pada analisis kombinasi jawaban yang meliputi jawaban benar, alasan salah, dan yakin, atau jawaban salah, alasannya benar dan yakin, atau jawaban salah, alasan salah, dan yakin. Kemudian, untuk pengembangan instrumen ini, pada awalnya itu terdapat 20 butir soal, yang kemudian divalidasi ke dosen dan diujikan ke kelas 12 siswa, untuk mendapatkan validitas dan reliabilitasnya, sehingga didapatkan yang valid itu ada 14 butir soal. Kemudian 14 butir soal ini diujikan ke kelas 11. Dan didapatkan 2 butir soal yang termasuk kategori miskonsepsi yang paling besar, yaitu soal nomor 5 dan soal nomor 8. Untuk soal nomor 8 itu miskonsepsinya sebesar 53,62%, sedangkan pada soal 5 itu miskonsepsinya sebesar 52,17%. Selanjutnya untuk persentase miskonsepsi yang paling besar pada soal nomor 8, soalnya seperti di slide ini, yaitu terkait pernyataan yang sesuai dengan garam natrium sitrat. Pada indikator ini itu tentang kesetimbangan ion dalam larutan garam dan miskonsepsinya yang paling besar. Sebagian siswa itu menjawab opsi B, padahal yang jawabannya itu opsi E. Kemudian kemungkinan yang terjadi itu siswa menganggap bahwa ketika dideteksi dengan indikator PP, senyawa garam yang bersifat basah tidak akan berubah warna menjadi merah muda. Padahal jika PP deteksi pada larutan garam natrium sitrat, itu larutan akan berubah warna menjadi merah muda. Dengan demikian dapat disimpulkan bahwa sebagian besar siswa belum paham dengan indikator PP. Kemudian siswa belum dapat membedakan sifat asam basa larutan garam, dan siswa tidak mengetahui informasi mengenai garam natrium citrate itu sendiri. Selanjutnya pada butir lainnya yaitu pada butir 5 soalnya seperti ini, yaitu terkait natrium karbonat yang merupakan garam yang jika di dalam air akan mengalami hidrolisis sesuai dengan reaksi. Nah, pada butir ini siswa mengalami miskonsepsi mencapai 52,17%. Sebagian siswa itu menjawab opsi A, sedangkan yang benar itu opsi B. Nah, kemungkinan yang terjadi itu beberapa siswa menganggap bahwa opsi A itu adalah reaksi hidrolisis, namun diketahui bahwa reaksi tersebut itu merupakan reaksi ionisasi. Kemudian siswa mengalami miskonsepsi karena belum paham bahwa hanya ion negatif dari asam lemah, senyawa garam atau ion positif dari basa lemah yang dapat bereaksi dengan air, sehingga sebagian siswa itu masih keliru atau belum paham dengan reaksi hidrolisis itu sendiri. Selanjutnya yaitu strategi terkait miskonsepsi itu melalui pendekatan konflik kognitif, yaitu ada 3 tahapan, yaitu pendahuluan yang dilakukan dengan penyajian konflik kognitif, kemudian konflik yaitu penciptaan konflik dengan bantuan kegiatan demonstrasi atau eksperimen, dan yang ketiga penyelesaian yaitu kegiatan diskusi dan menyimpulkan hasil diskusi. Mungkin itu secara singkat dari kelompok kami. Terima kasih.
Okay, can I ask?
Yes.
Ya, saya nak tanya macam slide 13. Slide 13. Okay, so di sini kamu memberi penjelasan kemungkinan untuk miskonsepsi kan? Kemungkinan. So, actually how you come to this conclusion? Bagaimana kamu sampai ke kesimpulan macam ni?
Karena dari sebagian besar jawaban siswa yang keliru, kemudian terdapat beberapa kemungkinan siswa berpikir seperti ini, seperti itu.
Okey, senang saja. So bila kamu buat kemungkinan macam ni, so selalu refer kepada literature. Refer kepada literature. So kalau you refer kepada literature, dia ada banyak sebab mengapa misconception telah berlaku, tetapi in your context, in your case, you are giving dia dalam literature ada banyak sebab. So kamu pilih salah satu sebab yang sesuai untuk konteks Indonesia dan kamu bagi kemungkinan dia. Bukan saja-saja bagi satu penjelasan yang tidak kukuh. Okay, so generally yang ini dia nampaklah instrumen, saya tak pasti jurnal mana kamu ambil, tapi dia ada instrumen 3 tier. And you also have showed the dia punya cara grading dia. So when is considered misconception? If tier 1 is correct, tier 2 is wrong, and tier 3 is also wrong, then it's misconception. Tier 1 correct, tier 2 wrong, tier 3 correct, also misconception. So you have referred to the literature. So then it's not a problem. But of course you need to report on the validation and reliability. Tapi saya nak komen tentang konflik kognitif tu. So that one whatever you mention itu adalah asas fundamental tau. 3 peringkat untuk teaching which is based on cognitive conflict. But apa yang kamu buat? Apa yang kamu buat dalam proses pengajaran yang menyebabkan tiga prinsip ini berlaku dalam kelas. So di sini kamu kata pendahuluan yang dilakukan dengan pengajian konflik dan penciptaan konflik dengan bantuan. So yang ini macam saya tidak akan setujulah yang kalau kamu kata kamu hanya bagi demonstrasi, kamu saja tunjukkan eksperimen, then you kata pelajar boleh melalui cognitive conflict. So if you ask me, I won't agree with that. Because for cognitive conflict to take place, the students' participation in the learning is important. Di sini kamu bagi demonstrasi. So kamu kata saja melihat pada demonstrasi, saja tengok apa yang cikgu tunjuk, demonstrate, you kata boleh berlaku assimilasi and accommodation. I think this is not possible. Especially student at this era in 21st century, I rasa dia tak boleh just tengok sesuatu. So probably this is not accurate. So you need to think about pendekatan cognitive conflict is okay. I agree. But how you do it in the classroom is not so accurate. So you kena fikirkan sesuatu yang lebih mencabar.
Lebih tajam.
Ya. Betul.
Ya. Kalau yang tadi Dr. Mages itu tajamnya karena ada apa? Defisiensi, apa istilahnya? Tadi Dr. Mages ada plausibility, intelligibility.
Yes.
Yeah.
And it's very explicit, So penglibatan pelajar ada.
Yeah.
Guru menyediakan sesuatu yang mencabar fikiran dia. It's not that tengok, lihat, lepas tu buat documentation ataupun follow prosedur. Okay, mula-mula isikan tabung uji dengan 50 ml asid. Lepas tu basahkan litmus paper dengan air, letakkan, itu adalah tradisional lah. That one we can teach in. When I learned chemistry, that time it was that way of teaching. But now you cannot do that anymore. Students will not sit and listen to you already. Things have changed. So the teaching that you show in the classroom, it should be something which challenge their thinking.
Alright.
Okay, so tengok balik lah.
Mbak Reti sama Mbak Rahma ada pertanyaan untuk Dr. Mages?
Jadi intinya itu untuk pendekatan konflik kognitif itu boleh, tapi dilakukan dengan cara lebih ke siswanya yang aktif gitu ya.
Meaningful.
Tapi sebenarnya itu punya kita itu menggunakan kayak video aplikasi gitu Bu, sebenarnya yang ini gitu Bu. Jadi maksudnya yang di sini itu penciptaan bahan untuk kegiatan demonstrasi itu menggunakan video eksperimen sederhana gitu melalui aplikasi gitu Bu, sebenarnya.
Tapi hanya belum mengarah tadi di materi itu apa gitu. Ya.
Jadi berarti nanti diperbaikinya langsung ke dalam materinya langsung tiap indikatornya gitu.
Seperti konsep Dr. Mages, maybe students hard to find to bridge the dissatisfaction. Jadi konsep yang CCM yang the first concept, the dissatisfaction, untuk bisa bridging ke strategi. Ini Dr. Mages sepertinya. Ya. Supaya yang tadi ketemu di miskonsepsi hidrolisis, mereka bisa letakkan gitu gimana?
So your question is students have problem of stating the dissatisfaction.
Yeah.
Betul?
Yeah.
Okay. So actually dissatisfaction itu adalah satu perasaan, your feeling, right? Kamu ada pelajar, kamu sebagai cikgu, kamu mengajar, betul? Student tu perlu rasa kurang puas hati. Bermaksud, bila student tu datang ke kelas kamu, mereka sudah ada satu idea, katakan acid base. They already have some kind of idea. So now that idea can be correct or wrong or misconception. So as a teacher, your responsibility is, kalau dia tidak tahu, kalau dia salah, kamu betulkan. Kalau dia ada miskonsepsi, kamu betulkan. Itu adalah tugas kamu sebagai guru. So, nak betulkan ini is not easy. Kamu mungkin rasa, okay, I am doing the best. So definitely the student has improved. But probably the student never go through anything. The student never experience any changes. So, in order for the student to experience change, tahap pertama adalah dissatisfaction, tidak puas hati. Bermaksud, pelajar itu sendiri, pelajar kamu perlu rasa tidak puas hati. Tidak puas hati dengan apa? Tidak puas hati dengan apa yang sudah dia punya prior knowledge. Dia tidak puas hati dengan prior knowledge. Bila agaknya dia boleh rasa tidak puas hati, dia datang ke kelas, cikgu tunjukkan knowledge yang baru. Cikgu so cikgu bila saya kata tunjuk, it's not like you demonstrate. You are actually giving some kind of new approach. You really challenge their mind. So when you challenge their mind, their prior knowledge and whatever the teacher say is not fitting. It's not fitting well. So for example, katakanlah acid base. Katakan acid base. So sekarang kamu nak pelajar mengetahui bahan-bahan, materials yang acidic and materials which are basic. So you give them a range of things. So you bagi toothpaste, you bagi coffee powder, just a house daripada dapur, semua barang. So bila student test coffee powder, coffee, pH menunjukkan acidic. But in the student's mind, coffee also acidic. Lower secondary school student. Coffee is acidic. I didn't know coffee is acidic. The student were all the while thinking coffee is acidic. But when you do the experiment, you ask the student to do, you actually give them a range of house kitchen things. They actually categorize. Okay, sekarang kamu kategorikan acid dan base. Bahan yang bersifat acid, bahan yang bersifat base. Okay, so bila dia tengok coffee powder, when they test, it's acidic. It is contradicting with their prior knowledge. So it's not so easy, it's not so easy. The moment they say, macam mana acidic? Dia tak boleh terima macam tu saja. You have to trigger them. You have to say, coffee is acidic. Toothpaste is a base. Why? So the learning, the triggering, it will create dissatisfaction. Kalau you bagi macam tu, okay, test, yang ini base, yang ini acidic, nothing will happen. But as a teacher, you need to challenge that.
Yeah.
That will create dissatisfaction. So they will come to the point, why the teacher keep telling that? So when also do something else, it also shows that coffee, let's say you give many Starbucks lah, apa-apa coffee lagi kan, so many coffee. All the coffee is also acidic. That means something is wrong. My understanding is not correct. So dissatisfaction.
Yeah.
So you cannot. That's why I don't agree with the demonstration where you just demonstrate the accommodation, assimilation happens.
Yeah. Alright. Thank you, Dr. Mages.
Yeah.
Terima kasih Mbak Rahma dan Mbak Reti.
Yeah.
Yeah. Okay. So I think this is enough for 3 groups presenting already. Dr. Mages, and your feedback already written and then just underlined by students to look back to the literature and then to make sure that the instrument is valid and then the data is also valid as well.
Yeah.
All right. Mas Gilang sudah ada di sini? Okay. Now we are in the end of the 4 meetings of my guests. We have already done 4 meetings. Start with I think about the misconception, about preconcept, and then we continue with the instrument to diagnose. Dr. Mages has already presented very instrument that we can use to diagnose the problems in the classroom. Yeah, but the most important thing is please make the unique what you have done with the misconception, especially based on the Indonesian context. That's the point. And then we go through the conceptual change model and then some instructional method that based on the CCM. You learn a lot from her. And then today, again, the one example how to do the CCM, and then a lesson plan, the learning plan that we can do, and in which grade the lesson plan is given?
For Malaysia is like 13 years, 14 lower secondary.
Okay, lower secondary school, yeah. Yeah. Okay. So Dr. Mages will send the sample of the lesson plan to me, and then try to elaborate, and then try to construct the new lesson plan. Continue with my course, after these 4 meetings.
Yeah.
All right. Good. Thank you very much, Dr. Mages. That's very, very important for us. That's why this pandemic is also beneficial, so we can see you. We can see you just without any burden with the Zoom meeting, and then Ibu Dr. Sri Aptina just send the greetings because she could not come today. So hopefully we can see another time and then collaborate more. We will talk more about the collaboration between USM and UNS.
Yeah. So
it should be USM 11 Maret. It should be USM, right? But
that's right. Actually,
Universitas 11 Maret USM, but we're not using USM, Dr. Mages.
That's right. The other day when I was writing, USM, that one also USM. Why they're using UNU? You are using
UNS. We have
UNS.
Yeah, that's the history, because the first time WIA is Universitas Negeri Surakarta 11 Maret. Now negeri is already chopped, and then SM, but because the other university has already used the USM, that's why we could not go through with USM.
Okay.
But the things USM and Sans Malaysia and 11 Maret, I think should be bonded more.
I will work on the MOU and MOA. I'm quite busy now. Next week I got a workshop. After the workshop, I will start working on it.
All right. Yes. Okay, thank you, Dr. Mages. Before you leave the Zoom meeting, there are 2 participants that would like to express their, I don't know what kind of thing, the words, maybe from PPK and PPA. That's what I wrote in groups. Please, Mas Haji.
Okay, thank you for Dr. Mages for the knowledge, for the practical knowledge. So I have so much more knowledge on practical, on how to identify students' misconceptions, and today is a great day because I can learn more about the STEM and then stream, because I want to actually be an expert in a STEM education. So I intend to if I can, I'm intending to because I'm in Islamic high school, how to integrate Islamic into the STEM education. So this is a great knowledge for me. This is a great this past 4 weeks has been the greatest weeks of my life, and it's thanks to you. And I am on behalf of Mr. Umam also. Thank you for giving us knowledge. Thank you for being here. That's all for me. Maybe Mr. Umam wants to have more. Okay, that's all from us. Thank you, Mrs. Norma.
Okay, thank you very much, Mas Haji. Mas Haji from year 2021, now from year 2020. Mas Gama or others, please. Okay, the internet connection.
Oh, okay.
Okay, Mas Gama, please, your time.
Okay, first of all, thanks, Dr. Mages. I just only say thanks to you about this new, great, deep understanding about the misconception. One thing, one of the materials that I remember that really takes my attention was about how to detect misconception by drawing. That's totally new for me. Perhaps some of my friends do. I am a representative of my friends, Magister student 2020. Apologize if during these 4 weeks we made some mistakes. That's all from me. Thank you, Dr. Mages. See you in another meeting.
Yeah, sure. Yeah.
Now your
Thank
time,
you so
Dr.
much.
Mages.
Yeah, thank you so much. Thank you so much for your nice, kind words. I greatly appreciate. I had a wonderful 4 weeks with y'all. I only hope that we don't stop here. All the students have got some idea on misconception. So, you know, at this point of time in the academic life, publication is key for everything. So even you want to continue your research in any part of the world also, when you publish in good journals, you are immediately recognized, you know. So go for it, and I'm here to help you. I will try my best to help. I wouldn't say I know everything, but I think I know certain points that we can make up to the good journals in publication. Thank you so much. And I had a very great time these 4 weeks with y'all.
Yes, thank you,
Right.
Dr. Mages. Thank you very much.
Thank you, Dr. Norma, for inviting me.
Yeah, we are very honored to have you here.
Right.
Yeah. Okay. Hopefully we see in near future, not near future, but in short time, because we still connected, and then try to do the more collaboration works, Dr. Mages.
Yep.
Thank you very much. Thank you very much, students. And also
Yep.
we have students all from undergraduate as sit-in students, so they learn about the misconception, but without doing something involved, but they learn. Thank you very much.
All right.
Yeah.
Right. Thank you.
Okay. Thank you very much, everybody. Have a nice day. See you tomorrow for the 2020 class, and then see you on Saturday for the 2021. Okay, Dr. Mages, thank you very much.
Bye-bye.
Bye-bye. Good day.
Bye. Good day to you. Bye. Bye.